So in this video, we're going to talk about how to simplify nth roots. So when we simplify square roots, you want to think about the coefficients and the radicand separately from the variables. So for example, if we're simplifying the square root of 72 x to the fifth y to the sixth, we want to separate it as the square root of 72, the square root of x to the fifth, and the square root of y to the sixth. And then we want to simplify the square root of 72 just like we've been doing previously. We find the biggest perfect square that evenly divides 72, which is 36, and when we simplify it, we get 6 times the square root of 2. For when we work with the variables, we want to find the biggest exponent that's divisible by 2, but less than the exponent we have. So for example, x to the fifth, we're going to rewrite as x to the fourth times x. Then when we take the square root of x to the fourth, all we have to do is cut that exponent in half, and we have x squared. So this is going to become x squared square root of x. Y to the sixth, well, 6 is already an even number, so when we take the square root, we just cut the exponent in half and we have y cubed. Then in the final step, what we do is we gather up all the terms that are on the outside. So we have 6x squared y cubed, and then we leave the square root of 2x under the radical sign. So we're going to do something similar when we're working with nth roots. So suppose we have the cube root of 128, x to the 13th, y to the 6th. So we're going to separate this as the cube root of 128, the cube root of x to the 13th, and the cube root of y to the 6th. The cube root of 128, we can separate that as the cube root of 64 times the cube root of 2 because 64 is the biggest power of n, right? In this case, n is 3. And so the biggest power of 3 that's 128 is divisible by is 64. So then we take the cube root of 64, and that's 4. So we have 4 times the cube root of 2. When you're working with the exponents, you want to find the biggest number less than the exponent that's given, but that's divisible by n. So in this case, n is 3. So the biggest number divisible by 3 that's less than 13 is going to be 12. So we rewrite x to the 13th as x to the 12th times x. The cube root of x to the 12th, we just take that 12 and divide it by 3, and we get x to the 4th. And then we leave it as the cube root of x. When we have y to the 6th, well, 6 is already divisible by 3, so we just go ahead and do 6 divided by 3, which gives us y squared. So final step, once again, we combine all the outside terms. So we have 4x to the 4th y squared, and then we have the cube root of 2x. Okay, so remember, if you're having trouble identifying nth roots and even square roots, all of that is given to you in that nth roots and square roots chart. So, an important note about absolute value signs. Sometimes you have to add an absolute value into a term in your final answer because when we're talking about taking roots, we are looking for the principal root, which is the positive value. So, if you're taking an even root of a variable and it results in an odd exponent, you have to add an absolute value sign to indicate you're talking about the positive value of the term. So, for example, if we're doing the fourth root of x to the 20th, that gives us x to the fifth. Well, since 5 is an odd exponent, x to the fifth could be a positive or negative value. So we have to add in the absolute value signs. If we're doing the fourth root of y to the fourth, that results in y, but remember 1 is also an odd number, and so y could be positive or negative, so we need to add in the absolute value signs. If we're doing the cube root of a to the 12th, that results in a to the fourth, and we don't have to worry about the absolute value signs because a is always positive. So for example, if we're trying to simplify the square root of 100 a to the 10th b to the 12th, we're going to use our strategies and go ahead and separate this out. So we have the square root of 100, square root of a to the 10th, and then the square root of b to the 12th. The square root of 100, well, that's a perfect square, so we just take the square root and that's 10. 10 is divisible by 2, so I can just take the square root and I have a to the 5th, but since it's an odd exponent, I'm going to go ahead and add in my absolute value signs. And then b to the 12th, 12 is divisible by 2, so I just take half of that and I have b to the 6th. So 10, absolute value of a to the 5th, b to the 6th. Okay, now let's simplify the square root of 28, a to the 7th, b to the 8th. So I'm going to once again separate this, the square root of 28, the square root of a to the 7th, and the square root of b to the 8th. And so the square root of 28, the biggest perfect square that evenly divides 28 is 4. So I have the square root of 4 times the square root of 7. The square root of 4 is 2, so I have 2 times the square root of 7. And then if I look at a to the 7th, the biggest number divisible by 2 that's less than 7 is 6. So I have the square root of a to the 6th times the square root of a. And then I take half the exponent, so I have a cubed times the square root of a. The square root of b to the 4th, well, 8 is divisible by 2, so I just take half that exponent and I have b to the 4th. So when I combine all my terms, I have 2a cubed b to the 4th, and then times the square root of 7a. And that's my simplified answer. So here I have negative square root of 28, a to the 7th, b to the 8th. So once again, I'm going to separate it. And when I have a negative in front, I like to put it with the radical that has the coefficient. And so once again, when I do the square root of 28 and I try to simplify it, I'm going to get negative square root of 4 times the square root of 7. So that gives me negative 2 square root of 7. A to the seventh, once again, I'm going to break it down as the square root of a to the sixth times square root of a. And so I have a cubed square root of a. Square root of b to the eighth gives me b to the fourth. So when I rewrite this, I have negative 2a cubed b to the fourth times the square root of 7a. So now let's try simplifying the cube root of 64 x to the 10th. So when I separate this, I have the cube root of 64, cube root of x to the 10th. Well, 64 happens to be a perfect cube because 4 cubed is 64. So when I take the cube root of this, it just gives me 4. The cube root of x to the 10th, well, the biggest number divisible by 3 that's less than 10 is 9. So I have the cube root of x to the ninth times the cube root of x to the 1, right? It's just x. So 9 divided by 3 gives me 3. So I have 4x cubed and then the cube root of x. And this is my fully simplified answer. Now let's try the cube root of negative 54, a to the seventh, b to the eighth. So we have the cube root of negative 54, cube root of a to the seventh, and then cube root of b to the eighth. So the cube root of negative 54, when I separate that, I can turn that into the cube root of negative 27 times the cube root of 2. The cube root of negative 27 is negative 3, so I have negative 3 times the cube root of 2. Cube root of a to the seventh, that's going to be the cube root of a to the sixth times the cube root of a. So the cube root of a to the sixth, I do 6 divided by 3, so that's 2. So I have a squared times the cube root of a. And then I have the cube root of b to the eighth, so I'm going to rewrite that as the cube root of b to the sixth times the cube root of b squared. So I do 6 divided by 3, and that's 2. And then so I have b squared times the cube root of b squared. So now let's pull out all the terms on the outside. So we have negative 3a squared b squared. And then we have the cube root of 2ab squared. And this is now our fully simplified answer.